What if I told you that the biggest planet in our solar system is hiding an ocean? But not an ocean of water. We're talking about a mind-bending reality hidden deep within Jupiter. You might think you know this beautiful striped gas giant from the textbook pictures. But what actually lies beneath those serene clouds is so extreme and honestly so completely alien that it forces us to totally rethink what planets are even made of. Welcome to this explainer.
So what actually happens if you fall into Jupiter? Well, to answer this, we kind of have to strip away the illusion of it just being a simple gas planet. If you were to put on a spacesuit and just drop in, you wouldn't just float peacefully through some clouds until you hit a rocky bottom. No way. You'd be descending into a giant, churning engine of physics that completely defies common sense.
Because as you fall past the cloud tops, you'd eventually be crushed by an unfathomable 4 million atmospheres of pressure. That is 4 million times the pressure you are experiencing right now at sea level. To put that into perspective, that is way, way beyond the pressure at the very bottom of Earth's deepest oceans. It's a crushing weight that fundamentally alters the way atoms themselves behave. Section 1. The giant's familiar face. The surface illusion of the gas giant.
Before we take that plunge into the deep abyss, let's just think about what we actually see from the outside. Take its most famous feature, right? The iconic Great Red Spot. This is a raging hurricane with wind speeds over 400 kilometers per hour, and at its largest known extent, this one single storm could have swallowed the Earth 3 times over. But here's the crazy part. This storm isn't powered by the heat of the sun like the storms here on Earth. It's actually powered by something called the Kelvin-Helmholtz mechanism. This brilliantly illustrates why Jupiter actually releases more heat than it gets from the sun. See, its immense volume is still compressing and cooling from its violent formation billions of years ago. As the planet shrinks just a tiny bit, it compresses its interior, and that generates massive amounts of heat. That internal heat engine is exactly what's driving those 400 km/h winds.
Section 2. Peering beneath the clouds. How the Juno mission maps the invisible. For decades, what lay beneath those swirling clouds was a total mystery. Until, of course, we sent a robotic detective to check it out. In 2011, the solar-powered Juno spacecraft launched, and it finally arrived at Jupiter in July of 2016. Now, its goal wasn't just to take pretty pictures, though it definitely did that. It was really there to peer into Jupiter's dark heart and figure out if the planet even had a solid core.
But how do you actually look inside a giant ball of gas? Well, you use gravity. As Juno sped around Jupiter, denser parts of the planet's interior would literally tug on the spacecraft, giving it these microscopic speed boosts. By meticulously tracking those tiny gravitational speed bumps, engineers could literally map the invisible mass hidden underneath the clouds.
Section 3. The metallic hydrogen ocean. The bizarre reality deep inside the planet.
And man, what that gravity data revealed is shocking. There is no solid surface to land on. If you keep falling, the gas doesn't suddenly give way to rock. Instead of hitting a surface, those crushing pressures force hydrogen gas to radically destabilize into this exotic state known as metallic hydrogen. This was actually theorized way back in 1935. Basically, at 4 million atmospheres of pressure, the hydrogen molecules just break apart. The protons lock into a grid, and the electrons are suddenly free to just roam around.
So the really crucial takeaway here is that the exact same hydrogen we know as a light gas on Earth acts exactly like liquid metal deep inside Jupiter. On Earth, if you want liquid hydrogen, you have to cool it down to nearly absolute zero. But inside Jupiter, that unimaginable pressure turns it into a highly conductive, sweltering fluid metal.
And because this metallic ocean takes up the vast majority of Jupiter's volume, it means most of the planetary matter in our entire solar system exists in a state completely alien to us. Seriously, think about that for a second. Jupiter is the largest planet by a massive margin. So if most of Jupiter is metallic hydrogen, then most of the planetary stuff orbiting our sun is literally a weird liquid metal.
Section 4. Generating the magnetic monster. The environment created by this metallic ocean.
Now, this swirling ocean of liquid metal isn't just sitting there quietly. It is highly active and incredibly dangerous. The churning metallic hydrogen acts like an immense dynamo. It generates these viciously strong magnetic fields, extreme radiation, and wild temperature swings ranging from near absolute zero all the way up to tens of thousands of degrees. And remember, throughout all of this absolute chaos, there is still absolutely no solid surface.
Section 5. A bizarre fuzzy core. Juno's most shocking discovery. Let's keep moving to the very center of the planet.
Because if the vast bulk of the planet is a metallic ocean, what exactly is at the dead center? Scientists fully expected to find a dense, solid rock, but instead they found this bizarre amorphous mass, where rocky material is just entirely dissolved into the surrounding fluid. I absolutely love this quote from the mission scientists. "We thought we were going to find an avocado, instead we found a bowl of chili, a hydrogen-fluid chili con carne."
It's such a great visual, right? This fuzzy chili bowl model completely broke existing theories. The old avocado model assumed a neat, solid rock core, like a pit. But this new reality is a massive, blurred transition zone. Rock, ice, and metallic hydrogen are all hopelessly mixed together in this weird state somewhere between solid and liquid.
And it is massive. Juno's data showed this fuzzy core contains about 20 times the mass of the Earth. Imagine 20 Earths, crushed, dissolved, and all jumbled up and suspended in this deep metallic soup.
Section 6. Rewriting planetary formation, beating the solar system's ticking clock. Which brings us to a massive cosmic mystery. How did Jupiter build such a massive, blended core before the young sun blew all the surrounding gas away? See, you're fighting against a ticking clock here. The early solar system was a harsh place, and if Jupiter had relied on giant rocks slowly crashing together, it would have taken like 100 million years to form. It would have totally missed the narrow 4 to 5 million year window before the violent young sun cleared the neighborhood of all its gas.
So, Jupiter had to grow fast. The breakthrough came when scientists added something called pebble accretion to their models. This process allows an infant planet to grow up to 1,000 times faster by rapidly gobbling up endless swarms of tiny, drifting pebbles. We're talking stuff less than an inch wide. It was basically a cosmic feeding frenzy.
And this rapid feeding frenzy explains everything Juno found. Swarms of pebbles accreted to form this massive core incredibly quickly. Then, that core's immense gravity pulled in the surrounding hydrogen gas right before the sun could blow it away. The intense energy of all those incoming rocks crashing together caused them to dissolve, creating that fuzzy blended state. And finally, all that gas formed the massive atmosphere we see today, trapping the core forever.
Which leaves us with a truly staggering thought to end on. If our very own local gas giant hides a fuzzy core and a massive swirling ocean of liquid metal, just imagine what mind-bending structures are waiting to be found in the exoplanets across the rest of our galaxy. I mean, we are just beginning to unlock the secrets of our own backyard. What impossible environments are churning away out there in the dark? Keep that in mind the next time you look up at the night sky. Thanks so much for joining me on this explainer, and I will catch you in the next one.